Okay, so we've got now the memory operator. We've dragged the Boolean output, or the Boolean value, into the output, and you can see that Boolean output appear. Something, just a side note here, interesting. We created our first memory operator up here in set memory. You can see him highlighted here in blue, and he's got the actual value associated with him. When we come down here into use memory, now that we've created another memory operator, we get him listed here. And he, of course, has no actual data underneath him, not like this particular memory. And this is, and you saw, we'll actually remove it so we can repeat the process. But even though this memory operator is not this one, this memory operator can access this guy's data and use him as an output or an input. In this case, we're going to use him as an output. So any memory operator that we create is going to be able to grab data from any other memory operator. And remember, that's on a per particle basis. Each particle stores his own unique memory values. Okay, we'll go ahead and get rid of that extra memory. And remember, our plan here is to say when the red particle, we want to get his Boolean output, and when that Boolean output is true, we're going to move him into the other group. So let's go ahead and come up here to the standard operators, get a group. We want that group to be switched to a green group. And we're going to go ahead and we need to know which particle to affect. We need to affect that red particle. And we need to have this turn on at a certain time, so we're going to expose the on input. And that on input is going to be driven by the Boolean value. So up here in set memory, when the red particle turns 80, it's going to turn on this memory. It's going to set that memory, this Boolean, with a Boolean value of true. And then this Boolean value is going to be recalled, and it's going to go ahead and be used either true or false to turn on this group. It's kind of a long explanation, but we want to make sure that it's clear. Okay, so if we go ahead and scrub now, let's just go ahead and see what happens. We'll get out here, and then as soon as it turns 80, boom, he turns green. What's happening here is, up here in set memory, red, his age is being fed into this threshold, and this threshold is not going to turn true until it reaches at least 80. And then this memory gets turned on, true value gets stored. So now this one particle here, his age threshold is true. His memory value gets set with true with his Boolean. So this memory slot for here, for this particle, is now true. And then we're going to go ahead and look up that memory at this step. Now this rule, this use memory, is actually being evaluated every frame, of course. And what's happening is it says, okay, take each red particle, in this case we only have one, take each red particle, look up his memory value for Boolean, use that as an output, and pipe it into the group. As soon as this is true, it's going to switch him into the green group, but it only turns true when he reaches 80. So up until 80, this is outputting a false every time, because this set memory has not been turned on and set yet. Okay, kind of a long explanation. Let's just talk briefly about a small pitfall you want to watch out for. If you end up using this nice new shift and drag with things like memory, you'll notice that it creates a clone of the memory, and it also duplicates the bool, I'm old, the Boolean inputs here. So now this value is located in two different places. This is really dangerous because this memory here, what if we accidentally grab the wrong one as an output? We won't really know, hey, which one of these is the one that we want to be dealing with. So if you do end up shift dragging, make sure you clean out the data by removing those data types from there. This way there's always only one memory value that you're storing without accidentally duplicating it. Something else, memory is very similar to data channels. You remember the data channels here in the particle group. We can add things like float, integer, 0.3, etc., and store these on a per particle basis. These data channels are great because they allow communication with the outside world in Max. They allow communication with things like Pyrocluster and Afterburn, Krakatoa. You can look up colors, density values, etc. Memory does not have that luxury. It's contained only within TP, at least until you could use a memory output to set a particle data. Let's say we want to just use this Boolean I'm old to set the data channel. So this is one way. You could also use memory to go ahead and set data channels if you needed them. Okay, so I think that's a pretty good simple example to introduce us into memory operator. Let's go ahead and we're going to stir this up a little bit. Here at frame 20, we're going to come back to particle draw. We're going to go ahead and create another particle. Oops, we removed them. Smooth move. Let's go ahead and do this. Put one here. We'll come out another 20 frames. We'll create another particle there, another 20 frames, and another particle here. Okay. So each of these particles is going to turn 80 at a different time. And so each particle, each of these red particles out here, is going to be keeping track of his own threshold, and each one has his own memory value, his own memory slot, where he's storing his own Boolean I'm old. Just like every particle stores his own data channel. These are unique per particle. Okay, and so as soon as one turns 80, 20 frames later, the other one, and then finally 20 frames later, the other one. Okay, so that's just a quick and simple introduction to memory. It's extremely powerful and flexible, especially because you can access data types from different memory operators anywhere in the scene. Very similar to data channels. And we're going to go ahead and move on, and we'll take a look at a little more complex example.